Hello, dear colleagues. I am Bruna Frasson, and I present to you the results of the work entitled Effect of Portland Cement Addition on Initial Dissolution of Gangue-based alkali-activated cement. Synthesis of alkali-activates involve chemical reaction between aluminosilicates and alkaline reagents. Addition of Portland cement is an alternative to accelerate chemical reaction and provides hardening at room temperature, therefore forming hybrid cements. In hybrid alkaline reaction, the chemical process begins with the dissolution of the sources of silicoaluminates and calcium silicates. Then condensation and polymerization. Coal mining industry in Brazil extracts around 6 million tons per year of coal mineral. However, 60% are impurities and generated by washing processes. Coal mining wastes contain mainly aluminium, silicon, and iron oxides. The wastes are composed by quartz, kaolinite, and pyrite. Effect of Portland cement addition on the alkaline solution of calcinated and non-calcinated coal mining wastes were analyzed in this work. Compressive strength and chemical stability tests were implemented to observe the influence of OPC, cement Portland, in mechanical properties of alkali-activated binders. Coal wastes were used as aluminosilicate, and it was oven dried and milled. Coal sludge was calcinated at 700 degrees Celsius for 1 hour and then designated as CST. The coal sludge non-calcinated has low content of silicon and aluminum oxides, but higher content of iron and volatile materials. But after the calcination, the CST presents more than 90% of silicon and aluminum oxides and low volatile material. The granular coal gangue were milled and showed more than 60% of silicon and aluminum oxides. The alkaline solution was prepared by dissolving the sodium hydroxide in sodium silicate. Then alkaline-activated binders were prepared by pre-mixing the Portland cement and wastes, then adding the alkaline solution. Cylindrical samples were filled and cured at room temperature. After 24 hours, the samples were demolded and sealed with PVC film. 3 series of alkali-activated binder were studied, using different aluminosilicates, the CS series, the CG series, and CST series. The chemical stability test was performed by immersing the samples at 7 days in distilled water solution for 21 days. The contact solution was subject to electrical conductivity test and chemical analysis at intervals of 1 hour, 7 days, 14 days, and 21 days. The color of contact solutions changed in the CS series, becoming more amber, and can be related to the reaction of iron and sulfur. Alkaline dissolution test consists of weight 1 gram of powder, adding 25 grams of sodium hydroxide, and mix it. The solution is vacuum filtered with a quantitative filter, diluted, and acidified. The concentration of dissolved aluminum and silicon was analyzed by atomic absorption. Silicon and aluminum ion dissolution from coal wastes increased over the time. CST series showed higher ion dissolution than this other series, CS and CG. Portland cement addition increases the dissolution of silicon at 60 minutes for all samples, but does not affect the aluminum dissolution in CS and CG series. The CS and CG series have different degree of dissolution, maybe due to lower silicon and aluminum reactivity in alkaline medium. Transformation of a kaolin during calcination leads to a metastable phase and can be related to higher leaching of silicon and aluminum from CST series. Silicon and aluminum amorphous have lower bond energy and higher degree of ion dissolution. The presence of more silicon species provided by cement port addition may justify the hardening of hybrid cements at room temperature, since the condensation occurs between silicates and the aluminated species. CST samples present higher mechanical strength than CS and CG series. Addition of Portland cement induces hardening at room temperature and increases mechanical strength. Alkaline dissolution of aluminum ions and silicon ions can be an indicator of mechanical development. The higher initial ion dissolution, the greater compressive strength. The aluminum dissolution at early stages of reaction plays a role in development of initial mechanical strength. Hardening of alkali-activated cement can be influenced by the presence of more reactive aluminum and the heat released from hydration of cement portion particles. The CST binder presented decreasing compressive strength after chemical stability test. It doesn't mean a deterioration of displacement, but the general effect of the water on aluminum silicates is weaken the bond strength of silica, so the capillary water can put some pressure on the material, thus reducing the mechanical strength. But the hybrid cements showed increasing compressive strength after the chemical stability test. Compressive strength may be affected by the continual hydration of anhydrous cement portion particles immersed in water. However, CS10 and CG10 showed after the chemical stability test a decrease in compressive strength and a volumetric expansion. This behavior can be related to the oxidation of sulfates, such as pyrite. The salt solubility in aqueous medium can be analyzed by electrical conductivity. The higher ion concentration, the higher electrical conductivity. The CS and CG systems presented the higher electrical conductivity and pH values after 7 days of immersion, which indicate that some of the alkalis and metal ions did not participate of the alkaline reaction and are free to leach. CST systems have lower electrical conductivity and pH values, thus the development of more stable microstructure. Hybrid CST systems present higher values of electrical conductivity at 7 days than the CST0, probably due to the addition of Portland cement, which leads to increase in leaching calcium ions. During the chemical stability test, silicon oxides leached more than the other oxides. Addition of cement Portland decreased the silicon oxides releasing, and the CST samples have the lowest values than the CS and CG series. Therefore, factors such as waste reactivity and calcium content can induce formation of stable microstructure, which results in less leached silica oxides. So, the main conclusions obtained from the experimental results are listed below. Portland cement addition influenced the alkaline dissolution of silicon and aluminum ions for all samples analyzed. The higher cement Portland addition degraded solution of aluminum and silicon ions for the CST series. Concentration of aluminum dissolution at 60 minutes can be an indicator of mechanical strength or mechanical development. Hybrid cements presents an increased compressive strength after chemical stability test. The immersion in water affects the hydration of anhydrous cement particles and positively influenced the hybrid cements. Electrical conductivity and pH were lower for CST systems, which can indicate formation of more stable microstructure. thank you all for your attention.